You're here because you're interested in machine learning. Okay, we have a mix of both. I think we got the right mix in here. My name is Chee, just call me Chee, a professor from business school, specialized in supply chain management, mostly on the analytics side. I help company use data from different parts of the supply chain, not just within the company, but suppliers, customer data. And then, like people say, you know, data is the new oil, but my focus is actually how to squeeze oil out of data. That's my focus. So I help company to realize benefit. It could be a very simple thing. Oh, I now know more about my products. I now know more about my cost or something else. But when clients come to me and want more complicated things like machine learning, artificial intelligence, we can do that as well. Yeah, that's what we are doing here for this company. I will explain to you the project from different perspectives, especially how you might be able to implement a machine learning-like data analytics project in general. I'll be more specific in the context of product returns. Now, many of us have seen all these things. We can label them buzzword, and we can label them as something that is too costly or too risky to adopt. I believe some of you have not tried, especially those on this end, blockchain, machine learning, artificial intelligence. Anyone has tried? You have a project? Do you have a data scientist? You do? Great. Yeah. How much do you pay for a data scientist?
Second.
How much do you pay for a data scientist?
I don't know.
You don't know. Okay. So we'll tell you a bit more about that price as well. At the University of Leeds, we have expertise in different areas, robots. We can have robots that flies and so on. We also learn to implement robotic process automation to automate some of your planning process, for example. And RPA has been used in finance, insurance, different sectors, but now it's coming to logistics, shipping, and also planning. For example, when you ask for insurance quote, nowadays quotations for your insurance is automated by these things, for example. Yeah, the same thing is applied to now shipping industry. Shipping rate can be quoted by this. And we also specialize in twins, digital twins, machine learning, artificial intelligence, because we have a very big data analytic institutes with different data scientists. We produce 180 MSc students in data science every year, big, and we apply it in different sectors, pharmacy, medical, health, as well as supply chain. Blockchain, we have blockchain projects with different companies, especially some of them sponsored by United Nations, where we get products from low-cost African countries. We want to trace them, and we have projects together with these kind of companies or organizations implementing blockchain. Now, they are all very expensive, very tricky. We don't want to touch them, but actually some of them, like the speaker just now, Andrew Fox, and actually some of them can be very useful. However, you want to be very careful about some of these implementations. They can be very, very costly, and when you fail, it could be very serious. So back to some of these examples highlighted by Professor Thomas Davenport. There are so many high-profile digital transformation projects that has failed, but they fail for some reasons. So you don't have to really feel threatened by these kind of examples. For example, GE. GE had learned a lot about artificial intelligence, machine learning in their own organizations. They started to think, maybe we can sell this as a product and service. They created a business unit for it, and they put pressure on revenue to this GE new division, right? And they failed. Why? Customer not ready? Or the solutions are not good enough? What's the problem? The problem is actually they forced this new business unit to earn money. And this business unit go earn money from inside GE. All right? Because they're under pressure for the revenue. And then you're not solving problem out there. You're not creating new intelligent, new tools for your different clients. So they're not growing. Lego, I worked with Lego for many years, and I was one of those who helped them to use point of sales, selling out data to predict demand in different markets. They started this more than 20 years ago. Now they have to stop this digital Lego projects. How sad, right? But there was a lot of investment in there, and then they failed. But I want to think about it from a more optimistic perspective. Let's look at Procter and Gamble. They are one of the most digital companies in the planet, is in the FMCG sectors. The benefit that they create out of trying to digitize, trying to use different technologies, is some of the different solutions that make them stay ahead of the curve in the FMCG sectors. So the question is not just, no, we are trying to put a lot of money into this kind of things, but they actually have many different projects that end up helping them to compete in a different space. All right? And many of these are used by many other companies, like Control Tower. That was the first sort of initial idea created by P&G, and so on. Right? Your cooperative planning process also came from P&G working with Walmart 40 years ago, 50 years ago. Right? These are all things that are created by your small little bit effort here and there, and machine learning could be part of it. So I started with this because the company came to me, a logistics company came to me and said, Chee, is there anything we can do with our data? Right? Can you squeeze some oil out of it? Sort of. And I said, well, we can try. And I worked with them for a few weeks, get some data, and then play with it and say, yes, there's a chance to do that. And we go for funding to get this sorted, for example. Now, some of us still in the waiting stage. All right? You can wait for your competitors or someone else to come up with an off-the-shelf solution. How nice there's an off-the-shelf solution for you. Okay? When it's off-the-shelf, you buy it. Are you the first mover? No. Can you gain advantage? Yes, some efficiency somewhere, maybe. Yeah. So that's a challenge that we have to recognize. I just come back to another example here. A taxi company I used to take. This is a taxi company in Leeds. All right. After some years, you have Uber. They come up with a web-based GPS tracking system. And the first time I used them, it was horrible. Absolutely horrible. All right. They improved it, but by the time they improve this is what Uber is doing. Okay? Well, okay, they're still very happy because the other non-Uber taxi companies are maybe less, it's still lagging behind them. But this, it's far, far away from them. What they can do is very, very far away from what Uber can do, because Uber can predict when do you have accidents, when do you have high traffic, when do you have more demand, when do you have more supply, and more importantly, how do you squeeze more money out of you? Okay? They change the price whenever it's a bit busy and so on. All right? That's what they're doing. Now, some of you think, this is not going to happen in logistics sectors. Wow. Okay? Some of these people who have done this kind of project for Uber are now starting a new company. They are going to disrupt the freight forwarding logistics industry because they want to create similar sort of solution out there. If you run a logistics company, you might say, all right, let's wait for another 20 years, it might come. But actually, it is coming very soon. Okay? There will be some intelligent platforms that will take over some of your physical activities or become the intermediaries that squeeze money out of your business. That's going to happen to, especially logistics company. Yeah? Well, we can think about this from a different perspective. Let's move on to the topic about product return. The reason why I talk about the technologies and the trend first and then the problem is because you need to integrate these two into, can this problem be solved by so-and-so technology? Okay, matching the solutions to the problems, for example. So we start with e-commerce because the logistics company came to me and said, we specialize in return. All the big names ask us to manage their return. Okay? The only thing they ask is lower the cost and do it faster. The logistics company said, no, I want to be the intelligent service provider, not just the transport service providers or return service provider. So they started to learn more about how can I understand my customer problem. And one of the problems is actually returns. It's free, easy, getting easier, because all the e-commerce company wanted to make it easier for anybody to buy without any reservation. All right? There are many good reasons why people think about that? One of the reasons is that there are one or two consultants who say, now if you have free or easy return policy, it will boost your sales by 357%. Do you believe it? A lot of companies believe this, e-com companies. Okay? So for them, they do whatever possible to make the return easier. They are also under pressure by someone else. This one company actually put your name under this league table and say, which one is easy returner, which one is less, which one is offer free, which one not. Right? You're being ranked. Your customers, consumers may see this and say, oh, all right, these are bad people or difficult suppliers, for example. Yeah? So everybody believes, yeah, let's make it lenient, let's make it easy. And then you have more sales. There's some truth in it. Lots of customers, return customers, keep buying because they also keep returning. Because they like it and they get the power, all right? And they get the choice, etc. So under this pressure, a lot of companies, I'll just give some examples, all right, in here. They are trying to make it easier to return, not just free or less cost. You can take longer time to return without any penalty. Once you return, and this is 7 days for super dry, but now 3 days for eBay, you get the refund instantly or in the next few days, as quick as possible. No question asked. Even the return product is faulty, whatever, no question asked, and refund. Under these competitions, competing to make return easier, everybody started to realize actually the return rate increased. Right? Now some of you in your sectors maybe have 5%, 2% return rate. It's not a problem. You're right, it's just a few hundred items per month. Yeah, it's okay. But some of the companies we work with would have 1 million, 2 million or more return per year to pay for. Imagine you're paying £1 or £2 per return process. That's quite a lot of money in there. All right. So product cost is increased because of lenient return policies, and no one can actually stop this trend in a way. Because a lot of online shoppers, easy and free return for them is the most important thing they look for in purchasing decision from you. They will be put off if the return is complicated. Now, for first-time buyer, they might buy from you after they have a complicated return experience. They never come back. That's the statistics that we found. And for some of the fashion returns, yeah, especially fashion, you have 25 to 50% return rate. If you have a fashion product, £20 points, let's say £20 is the cost, 25% return or 30% return means you need to make money. Yeah, because your profit is being wiped out. Give you some examples, some other companies. The worst case, Shop Direct would have 250 million return annually, 250 million item return. Okay? The company I work with love this because they are a logistics company. All right? It's a big revenue in here. But for fashion owners, it's a big problem. All right? Now, in some warehouses, you would have 120 returns per day to process. Okay? Do you have this kind of number in your business? No? So I'm working with some serious problems in here for some fashion companies. Why is it happening? There are some of us, many of us, we class them as genuine returners. You really wanted to buy something, but you got something not quite fit to your needs and so on. You're disappointed with the color, texture, size. Okay, you return. But there are actually many other returns that actually not so genuine. They can be fraud and abuse. Yeah, you can have returns that is coming from shopliftings and anything. You even have gangs that make money out of the returns. Okay, and the other one is actually consumer behavior is changing. We call it wall dropping. Your changing room is at home. Buy online changing room. Don't like it, return. Or you buy something for your daughter or son, and you want to ask your husband's opinion. You buy something, put it on the bed, ask your husband, look at it, and say, take this one, the rest go back. Okay? Or you have a party, okay, you don't want to buy that particular costume, you buy it, use it, and you return. For some brand owners, they don't charge you much, or they don't charge at all. Okay? So this is becoming very common. We call them wall dropping, we call them serial returners because they buy, return very frequently. You can't stop this kind of people, especially more and more the younger generation take this as given. Yeah? So that's our challenges in terms of the rise in return. Return can cost 60 billion in the UK. That's the statistics we got, estimation from different sources, but that could be the cost. All right. For some sectors, for example, toys, 60 billion is the whole volume globally. Yeah, all right, that could be big. And like you say, you are coming from different sectors. You are happy that your return rate is low, but in some other sectors, apparel, textile and clothing, that's the worst one. Yeah, okay. Just some statistics over there.
So do you go back, what does return rate blended mean? Because that's a different in the chart, in the table.
This blended.
Yeah.
Because in this there are many different categories, subcategories.
Right. Okay.
So they blend them together.
No, just because in that one, auto parts has a higher return rate than apparel, which I find.
You do have auto parts because of some parts not fitting into the right things. You can't specify the right things, and they go to the dealers. Dealers send it back. That can happen. Yeah. Okay. Okay. I'm trying to put a scenario here for you to understand why do we need to have machine learning, and this is why we have this project. Now, all the companies listed here are not the companies I work with. I have NDA with my own company, so I can't tell the names. All right. This is just an example. You buy something online, let's say ASOS, you know ASOS, yeah? As seen on screen, so there's no shop, you just buy online. And the customer say, I don't like it, you return. Well, ASOS give you papers, work to fill in and do return. Sometimes online, you can do it. You can return it through any different means. You go to post office, even Asda, Hermes to collect, etc. So easy, so convenient. And once this thing comes back to a logistics company appointed by ASOS, they will do the inspections and so on. The first thing they do is to register a return. When they register a return, ASOS will process the refund. Okay? Well, between ASOS and Clipper, for example, ASOS will have to give forecast to Clipper on the return quantity per week in the future. And they have a contract, usually open book contract on how much ASOS pay for processing the return. And it could be a pound or two. Eventually, you pay per return or even more, depending on the complexities of the process. And then you're hoping to see all returns are good and you can resell it in 100%. Is it possible? Sometimes not, because you have lipsticks and you have cigarette smoke, you have broken items, missing buttons, some even torn items. You have items which are a year old coming back, so you have faulty items. And the faulty items are the one that you do not make any money. Usually, it goes to discount or even charity, secondary market. Salvage is a process where you take away the lipsticks, you take away the smell, etc., and you pay more money to this guy to salvage the product, all right? But then you are hopefully able to sell it at a discount or something similar, okay? And we try to analyze this for some of our clients. For clients with 5-10% return, it's okay. For clients with 20-30% return, it's a big deal. They were talking about several £100,000 a year or up to million plus pound a year spending on this return cost. Yeah, could be big for some of them. So how do we solve the problem? Stop return. Have a very tough return policy. No one would return. No one dare to do so. Yeah. So the lenient policy is still there. Okay, we have to deal with. Can we better predict return? If we can better predict return, my warehouse will have the right resource, and then logistics company is not going to charge ASOS or the other clients too much. All right, you are better prepared for that. And of course, if you can predict return, means you understood many other reasons why people returned. and then you can deal with the returners. Exactly. Yeah? You've seen this in the previous presentation if you went to Andy Fox Lamasso's presentation. Give you some idea of what this artificial intelligence and machine learning is about. You are trying to mimic human-like intelligence to learn, to reason, to plan, to process particular input. Machine learning is just one of these AI tools. Okay, it's focusing more on instead of you create a program, step by step doing some task. If something happened, then do this. If something happened, then do this, and then charge how much money into this process, etc. That is structured process, but machine learning is not doing that. Okay, machine learning is a bit like a black box. They have learning algorithms that take data from your supply chain, and they try to see whether some data can explain return or not. When they see this data can explain return, they keep this data into the algorithm. All right? Yeah. So the algorithm actually change as you give more data to the learning algorithm. Yeah. So that's the thing that we do. So we provide expertise to create learning algorithms and fill in data, and then uncover some of the insights, and then allow this algorithm to predict return. That's what we do. You can predict returns, you can predict demand, you can predict your shipment lead time, and etc. Okay, that's what we think about. At the moment, we focus on learning algorithm. It works like this, slightly simplified version of what we are doing. You have training data. This data could be your historical data of the returns and other variables that might explain return. And then we play with it. We understand some of the reasons why return is there, and we develop some initial learning algorithms. And there are many different ways. We actually use the simplest machine learning method that we have, actually. Nothing sophisticated from our perspective, but for our clients, they are, too difficult. But this is very simple algorithm. And we fit more data into the algorithm, and then they learn. For example, based on last 2 years' data, I know I can predict the return for next week. But next week, I got more data for next week, and then I better predict the week after. Okay? That's how you keep changing your algorithm, because you learn more. Okay? How do we help companies to experiment, try this machine learning? We have, from a university perspective, actually we can offer some alternate solutions compared to you go to a company, you pay a consultant, or you go to one of these vendors out there who say they can do something for you. Yeah? A slight difference between us and them is that we don't have a tools or software to sell to you. Okay? We just want to play with the data and learn something. We work with you by cutting your costs, because we can go to what we call the Kdp Funding. Okay? Kdp is a government-funded project. They fund any innovation in company that can create efficiency or save money or create new business product and services. Kdp means Knowledge Transfer Partnership. All right? If you are SMEs, you get 50% fund. If you are a large company, many of you are, you get 30% fund. All right? That means we are able to use that money to hire a data scientist of this price, 24 to 36K per annum. Very cheap in the market. If you go to London, you ask for a data scientist, and what's the price of a data scientist?
I don't know. I would just say £100,000. Would that be accurate?
Yeah.
Okay.
In London, data scientists for finance, insurance, 100,000. Okay? Okay? No one is going to give this money. This is a fresh graduate pay. But you're getting a master degree student with 3 to 5 years business consulting and IT analytic experience because of the students we get for this. Okay? So it's actually low cost, much lower risk kind of project you could do. And you can access to professors in the universities because of this setting, because we wanted to do it with you. All right? So you got a lot of benefit in terms of cost. And then you get knowledge from the universities because we have people who can understand information system, how to design information system, data management. Some of the companies we work with simply had very basic Excel knowledge. We train them and they learn to use Power BI, for example. You've seen some example from the presentation, but lots of companies do not know how to do it. And we help them to create dashboard or learn how to create dashboards, and we help them to create algorithm. Now, most companies we work with can learn this from us. That means many of their staff, part of this project, became expert in this area. All right? This is a bit difficult, but slowly we are able to train some people in the organization, hopefully, who works with us. What we get, in fact, the machine learning part is not the most important thing for most of the projects we are working. It's actually all better data. Because the process demands for data. All right? And then we ask them questions about data. A lot of companies, supply chain people say, I don't know. I'm not sure whether we have it or not. And then they start to find out. And then they say, okay, this data are correct. Oh, actually, this data is in another database, etc. Okay? And then we ask the questions about simple things about information system. How is your data structured? We ask a question about what is your ER diagram? What is ER diagram? Entity relationship. You have a SKU, all right? In the SKU, you have SKU tables of your SKUs. You have your supplier tables about supplier information. When you have a purchase orders, SKUs is linked to purchase order, okay? When you do not have this link, you have nightmare to collect data, all right? And a lot of people buy softwares, implement things, and realize at the very, very end, I can't really tell this return is from which customer, which purchase order, because you have store return, online return mixed together. Yeah? When you arrive at a warehouse, you can't even know exactly who is returning, for what reason, from which purchase, etc. So a lot of problems is being uncovered here. They are solving this problem, and they have that means they have accurate data. Second one is increased insight. I'll show you some example on that. And then we move on to better predictions and customers. Better data, give you one example. In a reduced environment, you may have legacy order management system. And that could be one in the brick and mortar stores, one in the online, separate, or could be together if you're lucky. And when you ask your logistics company to manage the return for you, you allow them to access to part of the data, but they have a separate warehouse management system, right? Or you can ask them to use your warehouse management system, and then you have your own ERP. A lot of cases, what we realize is they do not actually connect. Yeah? Because they do not think about primary keys or SKU linked to purchase order linked to a return. Yeah? Okay? And they also realize actually they can't even answer our questions about IT, information system design. So that's the challenge with some of the brand owners we face. The other challenge we have been facing is manual process, manual extractions and manipulation of data. Sometimes it's okay to use it, but in this case, this warehouse logistics company manually takes some information out from here, create a report on return volume, and use that to invoice the client. Okay? They have done this for years. And we found errors everywhere. Yeah? Okay? Why do you do that? And then we ask them to find a way to work with the clients to automatically download all the return data to the report and invoice. Inside from an Excel spreadsheet, in some of the logistics company we work with, this is what they can do. Yeah? Your supply planner, demand planners, etc., possibly all can do this easily. Is there anything else they can do beyond this? Yeah? Can they go and collect the data and create some of the BI intelligence to visually create dashboard? Can they create graph like this and you move your cursors close to here, you actually know more about what is inside? Some of the Power BI tools, for example. Most of them cannot do this. And through this project, we actually train them to build this themselves. And they come back and say, oh, now I know actually more about, in some cases, in the fashion industry, do you think men or women, which one return more? Yeah, you have this kind of thinking. Yeah, there were some occasions and some months men to return more. So in size, okay, sizes. What size are the problem one? Size 14? Medium. Yeah, because it's in between. You see, in between. And this in between things means I'm taking 12 and 14, I'm medium and large, and then sometimes I realize, okay, I need a large one, and so on. In some occasions, we see all this inside. Now, then we go into color. What color has more return from male, female, and what categories have more problem with colors or genders or all sorts? Yeah? So we're having this insight, and we are creating this report on a weekly basis if the customer wanted this, and so on. All right? So the merchandisers actually started to say, oh, can you also make that for me? Oh, I want to see that connection. Yeah? So we started to see a lot of insights of this when we started to use multi-layers of data, colors, genders, etc. Together. And then I was asked a question about age. Yeah, age is really very, very important, but we can't do it because of GDPR. Okay? So we are restricted on that. We're asking our client to do something, but it's quite difficult. We also managed to automate some of the data feeds to remove all the errors that they have been creating for years. Okay, that's the kind of benefit I look into. You notice I put sample here. Okay, that is because I have NDA with my clients and I can't tell the exact number, so I replicate this in this example. But they are actually two examples of the return. When it comes to machine learning opportunity, the focus is I want to explain something. What can I take to explain this? Option number one, I use return data to predict return. The only thing is the historical data, historical data. But that is not the most powerful data. And here we actually realize e-com sales can be used to better predict return. All right? Very simple. You can have more variables that can be can put in here to predict return, but we start with just e-com sales. Very simple machine learning examples. All right? And we take historical data, we build the training data set, and we use some very, very basic machine learning methods. Random forest was mentioned before, and the others, XBoost regressions, and so these are just regression. All right? What's the trend? What's the link between one factors and another factors in the regression? Of course, you have time series here. All right, and we do the trainings, and then we start to predict next week's, next 2 weeks, next 3 weeks return, and next month return, and so on. And we know next week's return is more accurate than next 2 weeks return prediction, and so on. We know when we should stop, etc. Okay, but at least we beat the human forecaster. In terms of warehouse, we have clients who say, this is my return volume forecast for this warehouse for my product. And there are usually 40-50% error. 40-50% error means the warehouse would have prepared 40-50% less staff or more staff for your weeks. Okay? So a lot of cost is in there. How do you solve this problem? Of course, better predictions. That's what we're trying. Okay? So I just try to conclude this by looking into the benefit of the machine learning projects. Yeah? The improvements that we look at the moment, we only do forecasting at a very aggregate level. We do not look at it from an SKU perspective. All SKU, that goes back to a warehouse return. Can I improve the forecast so that the warehouse return process becomes very efficient? You are preparing on top the exact capacity to manage that. It was 50% accuracy for one client, for example. Right? We can actually use very basic machine learning method to increase it to 90% accuracy. What does it mean? Some warehouses have 5,000, 3,000 workers. Yeah? Sometimes you need 1,000 workers. Sometimes you need 5,000 workers. And now they need 5,000 workers in one warehouse because this is the return peak period. If you look at the graph just now, yeah, this graph. Right after Christmas, a few weeks later, okay, everybody returned things. Yeah, we can predict some of these different periods forecasts, quite accurately, up to 90%, and that's the kind of improvements we get. So we have cost saving in terms of labor, capacity, and so on. The other benefit mostly actually is on the other perspective that we did not focus on at the very beginning, but this is actually more important for the companies we work with. Okay, they now understand what happened to the data and what happened to the different information system. Well, in reality, they do not have to change to a new SAP or whatever ERP system. We just find ways to quick fix for them to link some data together to solve problem. And we help them to automate some of the processes so there's no more some of the data errors, for example. Yeah. The other thing is actually, which brings us to the insight, is the combined data. Okay, you have data at the retail site or brand owner site. You have data at the warehouse logistic company site. And everyone look at the data separately would not understand the entire return. And we put them together, we get an insight. Yeah. For example, specific brands will have specific return logistic solutions provided, and that actually discourage return. Not the policy, but the logistics options for return, etc. We learn that by looking into those data. Okay, and then we develop dashboard, and that will help us to understand the return on a weekly basis. We have weekly dashboard insight for our clients and also for logistic companies to look at. The next step, which we are trying to do now, is going down to category level. Right, you have different SKUs that belong to a category, and then also, of course, we go beyond this and go to SKU level later. This project we only have started about 6 months. We still have another 2 years to go. So the next thing is about supplier. If you run a fashion business, you buy from many different manufacturer suppliers. All right, the size X or M for one supplier is not the same as the other suppliers, annoyingly. Yeah. Okay, and that also costs some increase in return because the same client of yours buy M from you last time fit, buy M for you this time not fit, annoying, and that's the reason why now we started to shortlist suppliers that has got that kind of problem. Okay, SKU suppliers that has got that kind of problem, then we start to work with them and to address some of the size, color, textures problem based on the return reasons insight we get. All right. So that could also be linked to product characteristics and so on. And in the longer term, our idea is to take some of these variables to predict the returns of a new fashion product. All right. At the moment, we predict based on historical at the aggregate level. Actually, if you launch a new series of product of similar kind to the one that we have seen, we are going to predict that return for the business. All right. And in the longer term, we will put in some of the weather seasonality issues because whether the peak of the return is this week or next week, it does matter significantly to the logistic process. And that's what we have. We coded this actually in our database. Yeah. The other thing we coded very much is actually time lags, which we use to predict this one. Whenever you have a peak in e-com sales, is it 1 week, 2 weeks, 3 weeks that you will get the peak in return? And what's the volume? That's what we do. We use time lag to predict the return. Okay. So ultimately, when we gone through this and test all our machine learning algorithms and improve them, our big goals in the future is to have real-time prediction, hopefully at the SKU level, including current product or new product you want to launch in the future. So for new product, you don't even know your e-com sales, right? Someone forecasts the e-com sales, and someone forecasts the return. And we will set up a platform to automatically track the e-com sales, automatically track the returns. All right. We have historical data of another product similar to help us, guide us a little bit, but we are going to use this new data on a real-time basis to sort of reinforce our machine learning algorithm. Okay? That's what we're doing in our knowledge transfer partnership project. We still have another 2 years. It takes time to build this thing. For us, biggest learning is that no company is data ready. Yeah? Okay? We spend 80% of the time to fix data problem. Okay? But this 80% of the time us spent on fixing data problems help the company to learn. Yeah? I think Andy also mentioned that it's learning that actually is very, very important. If you do not do this kind of project, you do not learn, right? Until a point when there's off-the-shelf application out there, your competitor maybe is far, far ahead of you, right? But learning these kind of projects actually is preparing yourself. Some of the presenters says, oh yeah, actually there are already off-the-shelf platforms you can buy. Most of us cannot decide which one, right? But learning this gives you the insight and knowledge to better choose some of this platform, right? When a salesman comes to you and they talk about random forest, what? Yeah, how do you random the forest to predict things? You know, it's difficult to understand. But once you get into it and start a project like this, working with some of the other experts, and you start to realize, actually, yeah, you can better decide your journey, your choice technologies or things that you want to focus on. All right? And the other important thing that I do not mention here is that we started to see a group of younger tech-savvy employees working with my knowledge transfer associate, the person we hire, the data scientist we hire. And so we created an interest group or expert group, all right, going beyond Excel only to Power BIs and to machine learning. So that's another trend, okay? If you ask your boss, let's go and pay $100,000 to hire a new data scientist, the boss will say, oof, can't do that. But if you use this as a way to push or to pull interest people to learn, you have your own internal resource to start to learn. Who knows, one of your colleagues, you know, can be ready to become a data scientist themselves. And that happens, okay? And that's what we think, you know, is important for most companies. Again, machine learning is not the only things you should think about. You know, it's just something that helps you in your journey. Okay? Thank you. I'd like to have question discussions if you have any. Or are we out of time? Or